Okay, well, welcome back to part 2 for 2D vectors. So we're going to do a couple more examples that are inside your workbook here. And I do encourage you guys here to pause, give this a question to try yourself, and then we'll take it on together. Okay, and we're going to start this question off by just drawing these two vectors. Good skill. First one we have is 10 kilometers at 70 degrees south of east. So let me write that out here. So we have 10 kilometers at 70 degrees south of east. So if we draw our vector, or our northeast, southwest, the ones that really matter here are east and south. So I'm going to emphasize those two. And the key thing to remember here is the second letter. Remember, that is where you start your measurement. So that means that we start east. And then we're going to go 70 degrees south from there. So that would look like about this. So this would be 10 kilometers in length. And this angle right here would be 70 degrees. Starting at east, go 70 degrees south from there. Good. Okay, let's take a look at the other one. So now we have 18 kilometers at 80 degrees west of south. So I'll write that out. Okay, so 18 kilometers at 80 degrees west of south. So again, I'm going to draw the relevant axes here. We have west, we have south. And as we did before, kind of highlight the second letter here, which is south, because that's where you start. So I'm just going to highlight that. That's your starting location. Then you're going to go 80 degrees west from there. That's a pretty big angle. So this would be 18 kilometers in length. And this angle right here would be 80 degrees. Okay, so those are our two vectors. Now we know how to basically draw from the news expression. What we want to do now is add these two vectors together, tail to tip. So let me show you how that looks. Let's start. Oh, good. Let's start with the 10 kilometer, 70 degrees. So that looks kind of like this. So again, this angle right here, that would be 70 degrees. And this length is about 10 kilometers. Then what I need to do is add the next one to it to scale. And here comes the key for how to do these ones. What I recommend you guys do is to draw new axes at the tip. There's your north, south, east, west. And I'll put the relevant ones on here. Here's west and here's south. Because remember, you're going to add the next vector from the tip. And the next vector looks like this, as I've drawn on the right. So make sure you do it to scale. So it's going to be a much longer vector. That's going to be 18 kilometers. And this angle right here would be 80 degrees. Good. So now we've added these things tail to tip. And remember, the resultant goes from start to finish. So here's your start all the way to the finish. So that would be the resultant. And I want to mention one more thing about the angle for the resultant. What I want you to do when you show the angle is, again, put some axes here and realize that the angle has to be with respect to an axis. So you have a couple of options. You could choose this angle as theta, and that's with respect to the west axis. But there is another option. You could also put the angle here with respect to the south axis. Either of those two locations would be okay for the angle. Good? Okay. One more. And this one is often challenging for students. So here's what I want you to do to start off with for this question. I'm just going to get you guys to draw this tail to tip diagram to scale reasonably, and then just sketch the resultant, which will be the overall displacement. Can I get you to do that first? Just draw it and draw the overall displacement. Pause, give it a try. Let's see how you guys did. So we're going to go 30 meters north. To the tip of that, we're going to add 50 meters to the east. And then to the tip of that, you add one more, which would be 110 to the south. And the resultant again goes from start to finish. So here's where we started, there we finished, and we go from start to finish. That is your delta D. If you did that, nice job. That's how you do tail to tip. We'll come back to that. Let's now do the first question, which is to find the average speed. So if we look for V average, and this is a scalar, all it is how far did you travel and how much time did it take? Well, it's a scalar, which means we don't care about the directions at all. You simply have to do 30 plus 50 plus 110 and divided by the time of the journey, which is 140. That's it. That's all you have to do. So we love the scalars. And to 3 significant digits, I get about 1.36 meters per second. Okay, so that's average speed. Now, if we're going to do average velocity, though, we need to first of all figure out the displacement. And to do that, this is kind of the inspiration. You want to make a triangle. And when you make a triangle, you can see that we now have the angle for delta D, and we just need to know the sides to be able to do Pythag. Hopefully it makes sense that the horizontal will simply be 50 meters. And the vertical for that right angle triangle is 110 minus 30, which is 80 meters. Just subtract the two verticals and you have that. Then with that smaller triangle, we can now solve this for delta D. So we see that delta D will simply be the hypotenuse, which is a square root of 50 squared plus 80 squared. And that's about 94.34 meters. And then we can figure out the average velocity, magnitude anyways. If you're interested, not that you have to show this on an exam, if you want to show the magnitude of average velocity, you can use an absolute value. And that just means magnitude of. And that would simply be delta D over T. So the 94.34 and divide that by 140. And that gives about 0.674. That's the magnitude, but we also need to figure out the direction. So I'm just gonna, I guess I don't need that, do I? Copy. And I'm just gonna do the direction down here at the bottom. It's more than I expected there. Okay, fair enough. That's good enough. Now we can actually find the angle. So we can do tan theta is opposite, which is 80, divided by adjacent, which is 50. Take the inverse tan. And we get about 58.0 degrees. And what I recommend is, again, put, maybe I'll choose a different color here. If you put your north, south, east, west along this, this would be east and this would be south. And to make this nice and clear, we do something of something. But remember, the second letter is the axis that you start at. So in this case, the second letter would be east because that angle starts at the east axis and then you go south from there. So 58 degrees south of east. Done. Okay. Well, now you have all you need to know to be able to do all the tail to tip questions. I wish you all the best in the homework.